All right. So this is on page 72. Discontinuity in rational functions. So most of the rational functions have restricted domains leading to the different discontinuities, which again are all a review. We can have vertical asymptotes, horizontal asymptotes, slant asymptotes, and point discontinuities. So tell me, this point discontinuity, what's another word for that? What's another way to say it? Because remember, if you have asymptotes where your discontinuity is, it could be infinite. This is an infinite discontinuity. So if you have a point discontinuity, there's one missing, right? So what happened to it? It got removed, so it is removable discontinuity. Okay. So that is because that's going to help you remember what to do if you don't remember what to do. Because I know just because it's a review doesn't necessarily mean you remember it all, or that you always were able to keep it straight when you were doing it. Okay, because there's lots of different things that happen, and depending on what's going on, this is how you handle this one, and so forth and so on. So, point discontinuity. This is the first one we're going to look at. Point discontinuities, or holes in the graph, occur when a factor containing x is common to the numerator and denominator. So you need to, if it's not obvious, then you need to factor it out. Even if it is kind of obvious, still need to factor that out. Okay? So when we look at number 1, this is a rational, you can decide that. Then we get y equals, so if I factor the top, I mean, it is x squared, but it'll help if I look at it like this. X times x over, what's my GCF down here? 3x, right? And then that leaves me with x minus 2. Okay. So, do I have a factor that is common to the numerator and the denominator? Yes. Okay. So here's what happens when you're solving that, right? Now we have to take it into account. We can't just cancel it out and move on with our lives and pretend like it never existed. But when you cancel these out, aren't you removing it from the rational, right? So since you can remove it, that's your removable. So you can connect that if you haven't already. I feel like some of y'all don't always make those connections. So that means that what we have here is the one that we're knocking out in the denominator, that means x cannot be what? 0. Whatever you're canceling out, you set it equal to 0 and solve, so we get x equals 0. Okay? So that's my x value, that's not my point. But once I cancel this out, then what I end up with is y equals x over 3 times x minus 2. Turn that off, please. Right? So even though this is my original, it acts like this. Acts like this one, right? With a hole. And then we're going to have to figure out where that hole goes. So once you figure out what your x value is in that ordered pair, then once you've reduced it, you can plug it in. Well, when I plug in 0 for x, does it even matter what's going on in the denominator? No. So I plug in 0, that means it's at 0, 0. Then I want you to label your discontinuity. So this is a point discontinuity, or it is removable, but we'll just, So PD for point discontinuity. A little PD out here, remind you. Oh, that looks like an O. Because when you have to list a bunch of them, I want it to be obvious that you're telling me that there is a point in discontinuity, or maybe there isn't one. So I don't want you to just not have it answered or have a whole bunch of work and just have nothing. You need to be able to say that there is none, or this is what this point means, that sort of thing. Okay? We all good? Questions? Sound familiar? Yes? All right. So now let's look at number 2. Go ahead and on number 2, factor the numerator and the denominator. Factor them both. That's the only way you're going to be able to see stuff. All right, what do we get in the numerator? X minus 3, x plus 2. Do we all agree with that? Yes? This is the difference of 2 squares, so it's x minus 3, x plus 3. So when you look at it now, does it have removable discontinuity? Yes, it does. And it may have some other stuff too, but that's all we're looking at right this second. So when we have this, since I'm going to be able to cancel those out, I have to take the x minus 3 that I'm canceling out and set it equal to 0, which means x equals 3. So my point discontinuity is going to be an ordered pair where the x value is 3. And then once I cancel that out and I get y equals x plus 2 over x plus 3, then I just plug in my 3 here, and that's going to give me 5 over 6. So that's 5/6. There's my point discontinuity. Everybody okay with that? All right. Number 3. Is this one pretty easy to factor? Yeah. So in the numerator, what do I factor out? 2x. And that leaves me with x minus 3. In the denominator, I have 2x. So this one has a point discontinuity as well, right? We're going to be able to cancel those out, which means I set 2x equal to 0. So x equals 0. So my point discontinuity is going to be at 0 something. And then when I get my y equals x minus 3, when I plug in 0, what am I going to get? Negative 3. So there's my point discontinuity. Everybody good? Any questions? So were you able to keep up with what to do on which discontinuity when you did rationals before? I don't know. I know y'all did it. I don't know how long you spent on it. Sometimes you do things, but you spend like one day and you move on, so it didn't really solidify. But did you get confused between which was which, or it was all good? We're all good? Okay, awesome. All right, so vertical asymptotes. So these we will abbreviate as, obviously, VA for vertical asymptote. They occur when a factor containing x is unique to the denominator. Okay, so I'm not canceling anything out, right? This x plus 2, there is not one in the numerator. So x plus 2 is what I use to find my vertical asymptote. What do I do with the x plus 2? Set it equal to 0. So x plus 2 equals 0, which means my vertical asymptote is at x equals negative 2. Everybody okay with that? It's that easy. So you look at, can I cancel anything out? If I can, then it's not a vertical asymptote. And if I can't, if it's unique to the denominator, that's my vertical asymptote. All right. Let's look at number 2. What do I need to do here first? Factor. So y equals, what is the numerator factor to? Yeah, x minus 7 times x plus 7 all over x minus 7. So do I have a factor unique to the denominator? Unique. You know what unique means? It only lives in the denominator. So what can I do with these? Cancel them out, right? So do I have a vertical asymptote? No. So my vertical asymptote is none. Is there any discontinuity? Yes. What kind? Point. So we have point discontinuity. I know this is only asking about vertical asymptote, but so x minus 7 equals 0. So x equals what? 7. So my point discontinuity, the x value is 7. And then y equals x plus 7. So what's the y value then? 14. Question asked about vertical asymptotes, but in the end, you got to be able to find them all anyway. So there's no vertical asymptote. We good? Because we don't always get one. All right, so let's look at 3. Y equals, then the numerator, what's my GCF? 2, so that gives me x minus 4. In the denominator, that's a difference of 2 squares, right? So x plus 4, x minus 4. All right, so first of all, there's something I can cancel out, right? So since I can cancel it out, that means I do have point discontinuity, right? I'm looking for a vertical asymptote. I still have to answer that question. And I'm going to have point discontinuity. So x minus 4 equals 0. So what does x equal? Positive 4. So then what I have left here is y equals 2 over x plus 4, right? After I get my point discontinuity out of it. Because I'm using this to find my point discontinuity, not my vertical asymptote, okay? That's to get my point discontinuity. The thing you cancel out, that's what I was doing first there. Okay, so then when I plug in that 4, this is going to be 4 plus 4, so it's 2 over 8, which is what? 1/4. Okay, so there's my point. Now that I've got all that canceled out and I'm here, do I have a factor that's unique to the denominator? Yes, I do. It is x plus 4. So now I take this x plus 4, which is not going anywhere. I set it equal to 0. Now I get x equals negative 4. That is my vertical asymptote. The line x equals negative 4. Okay? Everybody okay with that? Any questions? Okay. You do this one on your own. Give you a minute to do that one. So do I have any point discontinuity here? No, it was already factored for me, so that's nice. How many vertical asymptotes do you have? 2, because you've got this one, which would be x equals 0, and you've got this one, which would give you x plus 5 equals 0, which is x equals negative 5. So I have x equals 0 and x equals negative 5. Any questions about that? All right, do the last one, or the number 5 rather. Once you get it factored to that point, what do you know for sure it has at this right now? What kind of discontinuity? Point, okay? So I'm going to cancel those out because x equals 0 for point discontinuity. Still going to have to answer my vertical asymptote answer, but point discontinuity. Okay? It's going to have an x value of 0. We'll figure out the y value in a minute. So then I get y equals 2 times x minus 3. So when I plug in my 0 for my x, 0 minus 3 is a negative 3, times 2 will give me negative 6. Okay, so then for my vertical asymptote, what is it? None, because it's a line, right? Everybody okay with all that? Yes? Awesome. All right, horizontal asymptotes. So there's 3 different versions of this. They occur when the degree of the denominator is greater than or equal to the degree of the numerator in a rational function. So when it's top heavy, okay, so horizontal asymptote, HA. Greater degree in the numerator would indicate no horizontal asymptote. So since x squared is up here, we've got x plus 3 down here. We're not even going to worry about the rest of them right now because it might have some other discontinuities, but right now we're just looking at horizontal asymptote. So since this has a degree of 2 over a degree of 1, right? This is the degree of the functions. Then your horizontal asymptote is none. That's your answer right there. You don't necessarily have to write that out. I just want to make sure that I don't lose anybody. So here I have a degree of what in the numerator? 3. And in the denominator, 2. So does it have any horizontal asymptotes? Nope, because the degree in the numerator is higher. So this one is none also. Easy enough? The highest exponent gives you the degree of the function, or the degree of the expression. All right, so then if it's bottom heavy, so the degree, bottom heavy in degree, greater degree in the denominator, would indicate horizontal asymptote of y equals 0. So here, what's the degree in the numerator? 0. This has a degree of 0, okay? This has a degree of 1. So this is bottom heavy, which means there's no calculations or anything, just that my horizontal asymptote is at y equals 0. Here I have a degree of 1 over a degree of 2. So I don't have any calculations to do either. It's bottom heavy, so my horizontal asymptote is y equals 0. Everybody good with that? All right. Tied in degree would lead to a horizontal asymptote where y equals the ratio. What does a ratio mean in math? Fraction. Ratio of the lead coefficients of the numerator and denominator. Okay, so these are tied, right? Degree of 1 over the degree of 1. I don't care about the rest. I'm not actually dividing, but since they're tied in degree, I just look at the leading coefficients, and so my horizontal asymptote here is what? Y equals 2/5. Number 6 is also tied in degree, right? So I look at the ratio of the leading coefficients. That's 2 over 2. What is 2 over 2? 1. So your horizontal asymptote, y equals 1. Everybody okay with that? Any questions? Because that's all a review, but if you have any questions, let me know, because y'all are just staring at me, and I'm assuming that's a good thing. I don't really know. Okay. So go ahead and glue that in. We're going to go ahead and do the slant asymptotes because that shouldn't take too long, and we'll get it done. I'll review you, and then you'll have time to work, which means you'll have more time to work tomorrow, too, if we just go ahead and get it all taken care of. Okay, so I guess, what was that? That would be 73, yeah. We'll put that on page 73. And then I'll change that on your calendar. Okay, so this is just more. I just didn't want to make it too small, so I made it another page. So now we're going to look at slant asymptotes, okay? So these would be abbreviated as SA. Slant asymptotes occur when the reduced rational function contains an x in the denominator and the numerator is 1 greater in degree than the denominator. 1 greater in degree than the denominator. Okay. It's found by dividing the numerator and the denominator. There's a few different ways. This is one of those times where you want to have the different tools in your toolbox to make sure that you are doing it the easiest way and you're not always just doing it the same way, which might be more difficult or not even possible when you can do that. So it says reduce. So we first want to see if we can reduce this at all. So the numerator, if I factor it, what does that factor to? Or can I factor the numerator? I can. It becomes what? X minus 3 and x minus 1, right? And then I have x minus 2 in the denominator. Can't reduce it, right? So even though I factored it, I wanted to see if I could reduce it, and it can help me with some other things. What I'm going to do now is actually go back to this, and I'm using this. The best way to attack this one, since the denominator is so the denominator is a linear binomial, yes, then synthetic division. Synthetic division is the way to go when the denominator is a linear binomial. So that means I'm going to use 2. Then it would be 1, -4, and 3. Okay. We should be pros at this by now. 1, 2, -2, -4, -1. Okay, so this is going to give me then x minus 2 with this remainder. What do I do with the remainder? Remember? Okay, yeah, I would put -1 over x minus 2 when I was actually writing this out. But for slant asymptotes, how do I handle that? Because that's not what our slant asymptotes, they don't look all weird like that, right? Do you all remember what you do with the remainder? You do nothing with it. You don't even care about it. Okay, so at this point here, like this is irrelevant. You just use this to write your equation of your slant asymptote. Sorry, Miss Archer says asymptote, and then when it drives me nuts, but then that starts to come out of my mouth like that. It doesn't matter how many times we correct her. She just thinks it's funny now, I think. So slant asymptote is y equals x minus 2. Y equals x minus 2. And the remainder is just, we don't even care. Okay. And it's a slant asymptote because it's not horizontal and vertical, right? There's some sort of slope other than 0 or undivided. Are we all good? Yes? All right, so then let's look at this next one here. So y equals, and then we're going to factor this. So I get 2x times x what? Minus 2 all over 2x. So what's going to happen to those 2 x's? They cancel out, and so your reduced one. So when I cancel this out, I still got stuff going on, right? Because that's going to be my point discontinuity, right? So x equals 0 for your point discontinuity. I keep doing that even though it's not asking me for it, because I don't want you to ever think that you can just cancel it out and move on with your life. Like there's stuff going on here. Point discontinuity at when x is 0. And then we are looking for the vertical. No, we're not looking for vertical. We are looking for slant at this point. Slant asymptote. So x is 0. So then this gives me y equals x minus 2. Well, do I have a slant asymptote? No, because it's not even a rational function anymore, right? And it says the reduced rational. So there's none here. But I can actually find the ordered pair for this, and it is -2. We all okay with that? Okay. Now let's look at number 3. Can you factor the numerator? I need 2 numbers to multiply to give me 6. That would add to give me 4. Does that even happen? No, that can't happen, right? So I got a couple options here. I can't do synthetic division. I could do long division, but this is really kind of short division, which is like a shortcut. When the denominator is a monomial, like here, so denominator is a monomial. We know what that means, right? One term. Okay. You could do short division. It's in quotes because that's not really a thing, but if you look up how to do short division, you're not going to find it anywhere. Because if we did it as long division, it's just a kind of a shortcut to doing that, is that you divide everything you can. I'm going to divide this one, and I'm going to divide this one, and then when I divide that, that would give me a remainder. Remember, we don't care about the remainder. So when I get this, 2x squared divided by 2x gives me what? Yeah, 2x squared divided by 2x is just x, and then negative 4x divided by 2x is what? Negative 2. So your slant asymptote then is y equals negative 2. You get the same thing if you do long division. It just is more writing and stuff. And you can't do that if it's not a monomial. Right? It doesn't work that way. And remember that it doesn't actually divide out to give you this because there is a remainder. We're just not concerned with it. Are we all okay on all that? would the horizontal asymptote be 0? Okay, so it is top heavy. So what happens when it's top heavy? So there's none. Okay. There's a lot to remember. That's why I said I know it's a review, but you got to keep a lot of it straight. So you have to go back through, okay, what does the vertical asymptote mean? What is the horizontal? And that sort of thing. So, and the better off, if you actually, use your notes. I know that y'all don't always use them, and especially when it's a review. But the way it's ordered, it's ordered as like top heavy, bottom heavy, tied in degree. And so if you can kind of picture that in your mind and then kind of keep that up with, it's none, and then y equals 0, and then we do something with it, and you can kind of just keep it in order, because there's a lot to remember, I know. All right, so let's look at this last one. We can't factor anything. I'm not even going to make you sit there and stare at it. When the denominator, now remember, in order to get a slant asymptote, the numerator can only be one higher in degree than the denominator, and that's what's happening here. But then the denominator here, so the denominator has degree greater, oh my gosh, I can't spell, or equal to 2. Okay. Can I do synthetic division with this? No. Can I do short division? No. So here the winner is long division. So we're going to have to do long division. This is going to give me x squared, x squared plus 2x minus 1. Divide that into 2x cubed minus 4x squared plus 9x minus 7. So how many times does x squared go into 2x cubed? 2x times, right? This is going to give me 2x cubed plus 4x squared minus 2x. Are the 4x squareds going to cancel out? Yes or no? No, because you're subtracting. Remember, you got to go in there and change all your signs. Don't be flying through it and making ridiculous mistakes. So these do cancel out. And then this gives me negative 8x squared plus 11x minus 7. So then x squared goes into negative 8x squared negative 8 times. So give me a negative 8x squared minus 16x plus 8. Go in there and change all my signs. This is going to give me 27x minus 15. Can I divide any more? No, this is my remainder. What do we do with the remainder? Nothing. We don't care, right? We're done. And so my slant asymptote then is y equals 2x minus 8. Everybody okay with that? We good? So these are just kind of pieces. If all it asks you for on the, on the different parts of the homework is all it asks you for is horizontal and all it asks you for is vertical, that's all you have to put. Make sure you're labeling what it is though, and you don't just put randomly none or some point or something. But it doesn't hurt to think about the others and maybe write them down so that, because eventually you got to think about them all together and you're not just knocking something out. Okay? Are we good? Any questions? All right. Good deal.